Assalamualaikum and a very good day to our lecturer and fellow classmates. Today, our group will be presenting our MAT263 case study entitled Solving a System of Linear Equations Using Augmented Matrix and Elementary Row Operations ERO. Before we begin with the case study, let me briefly introduce the topic. Linear algebra is one of the fundamental branches of mathematics that focuses on matrices and system of linear equations. It plays an important role because many real-world problems involve more than one unknown variable, making them difficult to solve using simple mathematical methods. Therefore, linear algebra provides systematic techniques that allow us to solve these problems accurately and efficiently. Among the methods commonly used are the augmented matrix and elementary row operations ERO. These methods help simplify a system of linear equation into a form that is easier to analyze and solve. Besides being widely used in mathematics, they are also applied in various fields such as engineering, computer science, economics, statistics, and data analysis, where accurate calculations and decision-making are essential.
The purpose of this study is to understand and apply the concept of augmented matrix and elementary row, which is ERO, in solving a system of linear equation. These concepts are used to simplify and solve equations that involve unknown variables. In this case, the method are applied to determine the exact mark obtained by student named Ali for his assignment, test, and final exam. Through this study, we can understand how linear algebra techniques can be used to solve real-world problems involving multiple variables in a systematic way. Let's move to the example of study case. In this problem, a lecturer wants to calculate the exact mark obtained by student named Ali. The total mark divided into three components, which are assignment in bracket A, test in bracket D, and final exam in bracket F. Based on the information given, the total mark obtained by Ali for all three components combined is 134 marks. Besides that, there are two relationships between the mark. Firstly, Ali's assignment mark is 10 marks higher than his test mark. Secondly, Ali's final exam mark is twice his test mark. So, from this information, it's required to determine the exact mark for assignment, test, and final exam by forming a system of linear equation. Other than that, it also required to apply the augmented matrix, elementary row operation, which is ERO, to solve the system of equation. So, the next presenter will explain the process of formulating the equation and the solving problem using this method.
Next, I will explain the methodology used to solve this problem. So the first step is to formulate the system of linear equation based on the information given in the question. So first, we need to determine the variables. So we let A to represent the assignment marks, T represent the test marks, and F represent the final exam marks. After we define those variables, we move on to step 2, which is to converting the information from the question into mathematical equations. So first, the total marks obtained by Ali for all three components are 134. So we write the equation. It will become A plus T plus F equal to 134. Next, Ali's assignment mark is 10 marks more than his test mark. So the equation becomes A minus A equal to T plus 10, or equivalently A minus T equal to 10. Lastly, Ali's final exam mark is twice his test mark. So we write F equal to 2T, which can also be rearranged as negative 2T plus F equal to 0. Finally, in last step, we combine all three equations to form one complete system of linear equation, which is A plus T plus F equal to 134, A minus T equal to 10, and negative 2T plus F equal to 0. So, this system of equation will then be solved using linear algebra methods to determine Ali's marks for each assessment component. So, after we complete the SLE, next we need to form of an augmented matrix. First, we need to arrange the variables in a consistent order, which is A for assignment, T for test, and F for final exam. We then take the coefficient of each variable from the equation and place them into the matrix. The constant of the right hand side of each equation are written after the vertical line. The first equation, A plus T plus F equal to 134, gives the first row 1, 1, 1, and 134. The second equation, A minus T equals 10, can also be written as A minus T plus 0f equals to 10. This gives the second row 1, negative 1, 0 and 10. And the last equation, f equals to t, can also be rearranged into standard form as f minus 2t equals 0, or 0a minus 2t plus f equals 0. This gives the third row 0, negative 2, 1 and 0. So, this augmented matrix is the matrix representation of the system linear equations, and soon will be used in the next part to solve the unknown variables using elementary row operations, or ERO.
Next is question B2. Solve the system of equations using elementary row operation. To solve the system of equations, we use a method called Gaussian elimination to turn our matrix into a simpler organized form. The main goal is to create a leading one in each row, which make finding the final answer much faster and easier. We start with our initial matrix. We already have a leading one in the top left corner. We use it to clear out the numbers below it by performing the row operation R2 minus R1 to get new R2. Next, we look at the second row. To get a leading one here, we take the row and divide it by negative 2 using the operation R2 divide by negative 2 to get new R2. This gives us a clean one in the middle, which is much easier to work with. With that new one, we can clear the entry below it. We add twice the second row to the third row with R3 plus 2 times R2 to get new R3, which turn the value below our leading one into a 0. Finally, we look at the last row. We have a 2 in the third column, so we divide the entire row by 2 with R3 divide by 2 to get new R3. This leaves us with a 1 at the very end of our diagonal. Next, transform the matrix into system of linear equations. So, it becomes a plus t plus f equal to 134, t plus 1 half f equal to 62, f equal to 62. Then, use back substitution methods. A equal to minus t minus f plus 134. This will become equation 1. T equal to negative 1 half f plus 62. This will become equation 2. F equal to 62. This will become equation 3. To find value of t, we substitute f equal to 62 in equation 2. So, t equal to 31. Then, to get a value, we substitute t equal to 31 and f equal to 62 into equation 1. So, a equal to 41. Hence, a equal to 41, t equal to 31, f equal to 62.
Hi, I will make the conclusion. So through the metric and ERO calculation that we have shown yearly, our group has to manage to identify the exact score for each assessment component for Ali. As shown on the screen, Ali's score are 41 for assignment, 31 for test and 62 for final exam. The total score is exactly 134, just like the initial information for our study. This proves that linear algebra theory is very useful practical tool for solving everyday problem, just as academic data management. That's all from our group. Thank you.